Hello and welcome to another video. My name is Haroldas, and here are creational design patterns that every developer should know. A design pattern is a reusable solution to problems that are common and well known. Think of it as a template offering best practice that you can apply in various scenarios. Design patterns are generally divided into three categories. Creational patterns deal with object creation mechanisms, trying to create objects in a manner suitable to the situation. Structural patterns focus on how classes and objects are composed from larger structures. Behavioral patterns are concerned with how objects interact and communicate with each other. So let's start with creational patterns. Factory pattern helps us create objects without exposing the creation logic to the client. Instead of using new, we use a factory method to create objects based on some input or condition. As an example, here I have an apple and a banana class. Usually to create a new object, you would just use the new keyword, and using the factory pattern, you could call the create fruit method, passing in the type of fruit you want and the values it should be instantiated with, abstracting away the actual object creation. Another common approach is to have a factory method that only accepts a string or an enum and returns an object based on that input. Use the factory method to create objects in a clean and flexible way, so you don't have to write the new keyword everywhere and can easily switch or add types later. The builder pattern lets you construct complex objects step by step using chain methods and can create different representations of the same object without changing the building code. As an example, here I have a car class with 4 properties. As usual, you can create the object using the new keyword. However, the builder pattern allows you to create the object step by step, chaining the methods, and by skipping some of those steps, you can create different variations of the same object. To implement the builder pattern, I created this car builder class where setting each of those properties is its own method. Notice how each method returns this. This is what allows the methods to be chained. You should use the builder pattern when you need to create complex objects with many optional parts. It makes the code easier to read and avoids messy constructors. The prototype design pattern is used to create new objects by copying or cloning the existing ones rather than creating them from scratch. To add this to any class, implement the iPrototype interface in your class, making sure that the clone method returns a new object with the same values as the current object. You should use the prototype pattern when you want to make a copy of an object, especially if creating it normally is slow, complex, or resource intensive. The singleton pattern ensures that only one instance of a class exists and provides a global access point to it. You can think of it as a global variable. You should use it when you need exactly one object to perform actions across your system. For example, a config manager, logging, or database connection. A common way of implementing a singleton pattern is to have a private static instance property with the same type as the class, and a public instance property to actually get the singleton instance, which contains a lock object that gets locked when trying to get the singleton instance, ensuring thread safety. The adapter pattern is like a translator. It allows incompatible interfaces to work together by wrapping one with another. As an example, I have iNewPrinter interface and an old printer class that is not compatible with this interface. To solve this, I created the printer adapter class that implements the iNewPrinter interface and takes the old printer as a parameter in the constructor. As you can see, it uses the old printer class printText method inside of the print method. Essentially, all the adapter class does is wrap the incompatible printText method with a print method that satisfies the interface. It makes sense to use it when integrating legacy or third-party code that can't be changed, or when you want to reuse any existing classes but don't want to change them. The bridge pattern separates an object's abstraction from its implementation so they can evolve independently. So here's a simple example. I have an iDevice interface that defines common functions that any device might have, like turning it on and off. Then I have 2 classes, TV and radio, both of which implement the iDevice interface. I also have a remote control class, which takes an iDevice as a parameter in its constructor. The key idea here is that the remote doesn't care what kind of device it is controlling, TV, radio, or something else. and the device doesn't care what kind of remote is controlling it. The two parts are connected through an interface, but they are independent. That's the bridge pattern. It lets you add new remotes or new devices without changing the existing code, so both sides can evolve and scale without breaking each other. The composite pattern lets you treat individual objects and groups of objects the same way. Think of a tree structure. You have leaves, which are simple end objects, and branches, which are groups that can hold other leaves or even more branches. The composite pattern says, let's give everything the same interface so you don't have to care whether it's a single object or a group. The pattern is made up of 3 parts. The component is a common interface for everything. Leaf, a basic object like a rectangle that implements the iGraphic interface and doesn't have any children. Composite, a group of components. You can think of it like a container that can hold other components. In this example, this is supposed to represent usage of composite pattern for a graphics editor. The draw method can be called on any of the shapes individually or on a whole group. It's perfect for tree-like structures, for example GUI elements, filter pickers, file systems, organization charts, or in this case a graphics editor. The decorator pattern lets you add new behavior to an object at runtime without modifying its original class. Instead of creating lots of subclasses for every feature combination, you wrap the original object with one or more decorators. It all starts with a component, which is a common interface for everything. The concrete component is the object that you're trying to add extra functionality to. A decorator class that has a reference to the component and adds the extra behavior. And lastly, concrete decorators, specific implementations that add features. You should use the decorator pattern when you want to add features to an object without changing its structure. It promotes flexibility over inheritance by combining behaviors dynamically. The facade pattern provides a unified, simplified interface to a system that may have multiple complex components working behind the scenes. In this example, I have classes that represent a projector, sound system, and lights. Instead of going through each of those and calling their individual methods, I have a home theater facade where I can call start movie method or end movie method, and it calls the appropriate methods on each of those classes. The facade pattern helps to hide complexity and makes the code easier to use. It's great for startup and shutdown routines, APIs, or wrapping complex libraries. The flyweight pattern helps you reduce memory usage when you have lots of similar objects. Instead of creating a new object every time, you share the parts that stay the same. This is called the intrinsic state, and you only pass in the parts that change, called the extrinsic state from the outside. The character factory has a dictionary of characters that are stored. When you call the getCharacter method, it checks if you already have that character created. If yes, then you reuse the same one. If no, you create a new one and store it in that dictionary. You should use the flyweight pattern when you have a large number of similar objects. These objects take up a lot of memory. Many of them share the same data. For example, thousands of characters on screen in a text editor or hundreds of trees in a game. The proxy pattern is used when you need to control access to another object. You don't interact with the real object directly. Instead, you go through a proxy, a middleman that decides whether or when the real object should be used. Common proxy types include virtual proxy for lazy loading, protection proxy used for access control, and remote proxy for distributed systems. Here's a very simple example of a protection proxy. iDocument is the subject interface. Secure document represents the real subject. The document proxy checks the user access. If the user is authorized, it then lazily loads the actual document, so the real object isn't created until it's actually needed. The proxy acts as a middleman. It performs extra checks, adds extra functionality, or even blocks access, all without changing the real object. You should use the proxy pattern when you need to control or manage access to another object. The repository pattern acts as a middle layer between your application and your data source, for example a database. It encapsulates the data access logic, allowing you to treat data like objects and focus on business logic. As an example, I have a user class, and in my repository interface I have generic methods for adding a user, getting a user by ID, getting all users, and removing it by ID. In my experience, the repository pattern is very useful in my day job. It allows to easily swap data sources, unit test by mocking repositories, and centralize data logic. In simple words, the interpreter pattern is like making your own small language and then writing a program to understand or interpret sentences from that language. In this case, I've got an iExpression interface with an interpret method, then a few concrete implementations of the interpret method, such as the number expression that will return a number, add expression which will allow to add 2 numbers, and subtract expression that allows to subtract 2 numbers. This is a static parse method that takes an expression string as input, then it splits that input string into an array of strings, and each string then gets interpreted individually. As you can see, if the token is a number, then the number expression gets called. If the token is a plus, then the add expression gets called, and so on. Here is a simple demo. I pass in a string input to the expression parser, and it splits the string, interpreting each individual token. You should use the interpreter pattern when you want to evaluate expressions in a custom language. Avoid this pattern if the rules or the grammar that you're trying to use is complex, as it can become very slow and messy. In simple terms, the template pattern is like creating a recipe with fixed steps, but letting others decide how to do some of those steps. In this example, I've got the beverage class acting as the template class, where most of the steps like boil water or pour in cup are already implemented, but brew method and add condiments are abstract and will need to be implemented by the subclass. Then each of the subclasses have their own concrete implementation of the steps that can vary. You should use the template pattern when you have a general process with fixed steps, but some steps can change depending on the object. You want to avoid duplicating code across classes that share the same structure, or you need to enforce a specific workflow but allow the flexibility in individual steps. The chain of responsibility pattern is similar to a customer service support system. Imagine this: you send a complaint support request, it goes to a junior support agent. If they can't handle it, then it goes to a senior support agent. If it's still unresolved, it goes to a manager. Each one has a chance to handle the request, and if they can't, they pass it along to the next person. This is exactly how the chain of responsibility works. It's a chain of objects, and each one decides, can I handle this? If not, then I'll just pass it along to the next one. In this example, I've got an abstract support handler class. It has a link to the next support handler and a method to handle the request. Each of the concrete implementations override the handle request method, adding their own logic on how to handle the request and when to pass it along to the next handler. Chain of responsibility is great when you want to decouple the request sender from its receiver. Also when you want to give multiple objects a chance to handle the request. You should avoid it if you need guaranteed handling, as none of the objects may end up actually handling the request. If the chain becomes too long or complicated, it can be hard to debug. The command pattern is a way to encapsulate an action as an object. In simple words, it's like writing down an instruction, for example, turn on the light, on a piece of paper. This would represent the command object, and then you can give it to someone, like the invoker, to execute later, or even undo if needed. It helps to separate what needs to be done, the command, from who actually does it, the receiver. In this example, I've got an iCommand interface with an execute method, a receiver, this is what does the actual work, and a couple of concrete command implementations. The invoker class, where it's possible to set a command and execute it. Use the command pattern when you want to decouple a sender from the receiver, also when you need to queue requests, log them, or support undo/redo functionality. The iterator pattern lets you access elements of a collection sequentially without exposing the collection's internal structure. A simple example of this is a Spotify playlist, where you can go through the songs one by one by pressing next or previous without having to worry about how those songs are actually stored. In this example, I have a book class with a book collection interface that requires an iterator, the actual iterator interface that can tell if there is a next element and a method to get the next element, then a concrete book collection called library and a concrete book iterator. Now I can access the book collection, getting books one by one using the iterator without knowing anything about how they are stored internally. Use this pattern when you need to support multiple traversal algorithms such as forward, reverse, filtered, and you need the same access to different types of collections. In the Spotify example, the song can be stored in the database and be streamed to your device, or it could be stored locally. However, you use the same iterator to iterate the collection of songs. The mediator pattern is about having central object that controls how different objects interact, so they don't talk to each other directly. You can think of it as a middleman. In this example, I am applying the mediator pattern to a chat room implementation. The iChatRoom mediator interface defines how users send messages. The concrete mediator manages users and delivers the actual messages. Each of the users gets a mediator, aka the chat room, assigned when creating a user, and they can only communicate to other users via the mediator and never directly. You should use the mediator pattern when you have many objects communicating with each other and you want centralized control over that communication. The memento pattern is like a save game button in a video game. It gives objects the ability to save and restore their state without exposing their internal details. This example covers memento usage in a text editor. The editor memento class is used to store the editor state, also known as a snapshot object. The editor is the originator. It's the main object that can create and restore snapshots. Think of saving and undo functionality in a text editor. The history class is the caretaker. It's using a stack to keep track of mementos, the snapshot objects. Common use cases for Memento pattern are undo redo functionality. In games it can be used for saving and loading progress. It can also be used in form wizards to step forwards and backwards. The observer pattern is about automatically notifying multiple objects when something changes. So you can think of it like subscribing to a YouTube channel. When you subscribe, you become an observer. When the channel uploads a new video, the subject changes. All subscribers are notified automatically. In this example, I have an iObserver interface for objects that want to receive updates, an iSubject interface for objects that can be observed, a weather station, which is a concrete subject. It keeps a list of all observers, and you can also register or remove them. And when its internal state changes, it notifies all of the observers. Then I got a couple of concrete observers, phone display and window display. You should use the observer pattern when you have one-to-many relationship, one subject and many observers, when you want automatic updates when a subject state changes, and when you want to decouple the subject from its observers. The state pattern allows an object to change its behavior when its internal state changes. The key idea is that instead of using lots of if or switch statements, you create separate state classes and the object delegates its behavior to its current state. In this example, I have an iPlayer state interface with a press play method, media player, a context class holding the current state, and play state and pause state, concrete implementations that implement the behavior of those states. You should use the state pattern when an object's behavior depends on its state, or if you want to avoid complex if/switch statements. The strategy pattern allows you to define a family of algorithms or behaviors and make them interchangeable at runtime. To demonstrate this, I use the basic payment system example. The iPayment strategy interface defines the pay method. Then I've got concrete strategies such as credit card payment, PayPal payment, and Bitcoin payment. These implement different behaviors. And the shopping cart, which is context. So based on the selected payment method, it uses a different strategy object and delegates the payment to it. You should use the strategy pattern when you have multiple ways to perform a task and want to choose at runtime. If you want to avoid lots of if, else, or switch statements, and if you want your code to be flexible and open for extension. The visitor pattern lets you add new operations to a group of objects without changing their classes. In this example, I have an iVisitor interface, item element interface for objects that can be visited, book and fruit concrete elements implementing accept method, and shipping cost visitor, concrete visitor implementing the operations. You should use the visitor pattern when you have different types of objects and want to perform new operations on them. You want to add new functionality without modifying the existing object classes. For example, this can be used for tax calculations, reporting, exporting, or applying discounts. Like and subscribe if you found this video helpful. Thanks for watching and see you again in the next one.